Good afternoon to all of you. Myself, Professor EMI-Active from SND College of Engineering and Research Center, Yoga. Now, today we'll in previous video we are already started the new topic, that is measurement of power in a three-phase circuit. Now already in previous video or previous lectures, we already studied the electrodynamometer type wattmeter, LPF type wattmeter, and polyphase wattmeter. Now today we are discussing the new topic, that is two wattmeter method for the measurement of power in a three-phase balanced and unbalanced relay. Two wattmeter method can be employed to measure the power in a three-phase, three-wire star or delta connected, the balanced or unbalanced relay. In a two wattmeter method, there are two voltage coils and two current coils are present of each wattmeter. Wattmeter, suppose what wattmeter 1 and wattmeter 2, the each having one current coil and one pressure coil. That means there are two current coil and two pressure coils. Suppose the first current coil are connected in series with the phase R, and second current coil are connected in series with the phase Y. Then the potential coil of wattmeter 1, which is connected in between phase R and phase B, and the pressure coil of wattmeter 2, which is connected in uh, between phase Y and phase B. It means that the two current coils are connected in series with the two separate phases, and the pressure coil of both the wattmeters are connected in between one phase of corresponding phases, which is connected in which have connected current coil, and this will the another point which is connected to the third phase. Means suppose current coil are connected in between R and Y phase, then the pressure coil is connected between R and B and Y and B phases. This is the connection diagram of three-phase measurement of three-phase power by using two wattmeter method. When the supply is given to the circuit, this is a star connected load. This is a star connected load having the impedances Z1, Z2, and Z3. Due to that, the current flowing to the R phase, this is called as line current, and the current flowing to the Z1 phase, it is called as phase current. In a star connection, the phase current and the line current and a phase current are both equal, but the voltage of each phase, that is phase R, that is ERN, phase Y, EYN, phase voltage of B phase, that is EBN, and the line current, this is RB and YB. Means the line voltage and phase voltage are different in the star connected load. For the considering the figure, the W1, the current flowing to the current which is flowing to the wattmeter 1, that is IR, and the voltage across the wattmeter 1, that is VRB. IR and VRB means the reading of wattmeter 1 is IR into VRB into cos of angle between IR and VRB. The current flow into the wattmeter, the current coil of wattmeter 2 is IY, and the voltage across the pressure coil of wattmeter 2 is VY3. Then the wattmeter reading is the product of voltage and current. That is W1 is equal to IR into ERN minus EBN. Suppose BRB. BRB means BR minus VB. VRN minus VBN means the difference between the two voltages. The difference between the two voltages, that is called as line voltage. Or the difference between the two phases, it is called as line voltage. Then the wattmeter reading 1 is IR into VRB, and the wattmeter reading W2 is equal to IY into VY. That is, this is your equation. Now by adding the wattmeter reading 1 and wattmeter 2, it is IR into ERN minus EBN plus IY into EYN minus EBN. Therefore, by solving this, IR into ERN plus IY into EYN minus EBN into IR plus IY. But you know that IR plus IY plus IB is equal to 0. This is the phasor addition of the addition of all the current is equal to 0 in a three-phase circuit. Therefore, IR plus IY is equal to minus IB. Therefore, IB into EBN. Therefore, this is the power of phase 1, power of phase 2, and power of phase 3. This means this is the total power. The total power of the three-phase circuit means the W1 plus W2, it is the total power absorbed in the three-phase loads at any instant. Means by using two wattmeters, addition of two wattmeter reading, this is called as three-phase power. Total power consumed by the three-phase load. This is another connection diagram for the delta connected system. The connections of both the wattmeters are same as like star connection. Only difference in the load, that is in first figure this is star connected load, and in that the delta connected load. In star connected load, the line current is equal to phase current, and the phase voltage and line voltage are different. But in delta connection, the phase voltage and line voltage are both are equal, but the line current and phase current are different. But the line current and phase current are different. These are the main difference in the star connection and delta connection load. In that figure, the wattmeter reading is W1 is equal to IR into VRB. VRB means this is the voltage across phase 3. Phase 3 VRB. But the IR is equal to IRY minus IRB. IRY minus IYB. The wattmeter reading W2 is equal to IY into VYB. But the IY is equal to IYB minus IRY. This is your W1 reading. W1 is equal to IR is equal to I1 minus I3, means IR minus IB. Therefore, the voltage across the W1 is equal to ERB. Therefore, W1, the reading of the W1 is equal to the added product of both voltage and current. Then W1 is equal to ERB into I1 minus I3, and W2 is equal to the current flowing through the current coil of W2 is IY is equal to I2 minus I1, and W2 the potential difference across the pressure coil of the W2 it is EYB. Then the product of both W2 is equal to EYB into I2 minus I1. I2 minus I1. Therefore, W1 plus W2 is equal to addition of both the readings ERB into I1 minus I3 plus EYB into I2 minus I1. By solving this, then ERB into I1 minus ERB into I3 plus EYB into I2 minus I1 into EYB means I1 into ERB plus I1 into EYB, sorry, I3, this is your I2. In that, this is your I2 EYB minus I3 ERB minus I1 EYB. Then I2 EYB plus I2 EYB plus I3 EBR. The voltage will be changes. The potential difference is changes. Then it will be minus, it will be converted into plus minus I1 into EYB plus EBR. EBR. This will be converted into minus sign. Will be converted into minus sign. But that is ERB minus ERB is equal to ERB. Then EIB plus EBR plus EYR is equal to 0. Means the potential difference of the all the three phases, the summation of all the three phases are 0. That means the potential difference of all the phases is equal to 0. Then W1 plus W2 is equal to I1 ERY, that is power of first phase, plus I2 EYB, that is power of second phase, plus I3 EBR, that is power of third phase. The addition of all the phases is equal to P, means the W1 plus W2, it gives the total power consumed by the three-phase load. The power measured by 2 wattmeter method at any instantaneous power by the phase loads connected in three phases means by using 2 wattmeter method, we can find the value of power consumed by the load, three-phase power consumed by the load. This is a phasor diagram for measurement of power of polyphase system using 2 wattmeter method. This is your VR, VY and VB. Both the three phases are, this is a star connected load. This is a phasor diagram of star connected load. Both the three phases are split into one phase difference between each phase is 120 degree. In according to this diagram, the voltage across wattmeter 1 is VRB and voltage across wattmeter 2 is VYB, means VR minus VB and VY minus VB, means in both the conditions VB is minus. VB is minus. That's why to take the VB in opposite direction, that is your minus VB. The phasor addition of VR and minus VB, it is your VRB. The phasor addition of VY and minus VB, it is VYB. The angle between VYB and VY, it is 30 degree. The angle between VR and VRB is 30 degree. Means the wattmeter 1 reading, that is for VRB, the wattmeter reading is IR into VRB into cos of angle between VR and VRB. It is the phi angle, means it is 30 minus phi. It is 30 minus 5. And the angle between V IY and VYB, it is 30 plus 5. And both the addition of both wattmeter 1 and wattmeter 2, we can find then the total power is equal to root 3 VL IL cos phi. This is the method for measurement of three-phase power by using two wattmeter method. Okay, so stop here. Thank you.